Hey all, hope you're doing great. So welcome to Conf42 Platform Engineering 2024. Today we will deep dive in the importance, the role of observability and platform engineering. So here is me, Neel Shah, a developer advocate and middleware and observability platform, building various DevOps communities, running communities like Google Cloud, CNCF, Docker, mentored more than 15 plus hackathons. So yeah, let's go ahead. What's in store for us? Why absolutely matters in platform engineering. So what are the key benefits? First is optimizes resource allocation. It will drive the event in the sense like is there resource scarcity or the resources are abundant. It can easily analyze from the logs from the matrices. Access accelerates troubleshooting. From logs, we can easily, not easily, but yeah, we can get a lot of things about the troubleshooting, how the error will be going. EXA's enhances developer experience, improves reliability, enables data-driven decision making. Decision making always happens from understanding the data, and data plays a quite important role of our next future predictions. So we will discuss all of these points ahead in our next presentation slides. So core objectives of observability. Let's understand it first, and then we can go ahead. The core objectives are three major: log management. So we collect different type of logs, application logs, product log, service logs, different sort of logs to understand the performance, the impact of the behavior of the services which are going on. Gathering matrices, events to understand the performance health, and to try to understand the matrices in the graph format to understand it in a better way. So it gives. So if you monitor and troubleshoot the applications proactively, then your application would have less downtime and would have higher performance with more efficiency. That's the general thing, but yeah, telemetry always helps you to improve your application. Next is tracing. Traces track the journey request through services. It can help to understand the bottlenecks, the issues which are laying down behind your performance, which are downgrading. So it will help you to understand what could be the actual reason of that. Let's understand the role of the observability. First, first is optimize resource allocation. The correlate usage data what system demand to scale resource proactively and efficiently. So we have data of our previous application of how the application have worked, or let's say how a single piece of product has been sold. So in that manner, we can understand the demand, and in same manner, we can understand how many resources are required more in future. In that sense, let's take one example: this proactive scaling. By monitoring CPU and everything, teams can understand in which sort of scenario they need to scale up the resources, scale down the resources, and when is the peak time, when is the low time where they need to upscale. Teams can easily understand from observing their applications. Next is cost efficiency. Agility literally helps to reduce your cost, definitely, because some of the resources are under provision, and if you don't know that only 10 or 20% of the resources are used and you are paying 70-80% more money, then it can definitely you can definitely understand from the monitoring matrices and everything that you need to downgrade your resources in that scenario, which can impact your cost billing a lot. Next is expert troubleshooting. So we can quickly identify and resolve issues by logs, traces, matrices effectually. So for root cause analysis, one of the good example is root cause analysis. So for that, engineers can trace issues back to their origin, whether it's misconfiguration. But if the monitoring already is not set up, then it will be very hard to get what's the actual error or what's the actual problem they are facing. So it eventually helps. Next is incident response. So real-time alerts. So if they are using some of the platforms for observability, then it can definitely alert them, and so they can have a lower downtime and optimize their product or optimize their services in that particular time. Next is enhance developer experience. The developer can understand in that scenario what should be the better thing, how the performance of the applications is better in production, or is helping them understand how some changes in new application could affect the sales or anything, sales or services or anything. Yeah. From monitoring, from because it will lessen the time for troubleshooting and more time for building their new features. Is improve reliability, continuously monitor, refine platform components for better uptime and stability. So uptime monitoring other tool track systems and immediately gives alert. So if you have proper observability setup, it will immediately you can have a message on Slack, message on emails, message on Teams, anywhere. So most of the observability platform gives you this. So you got the alert, then you can definitely try to troubleshoot and get back your application in live. Anomaly detection. So advanced observability solutions use machine learning. We will definitely try to get this in our next slides where we will discuss what are the future trends in observability. Yeah, ML, AI definitely help you understand the anomaly detection. Yeah, that's a great part. Let's have a lean example. On a shopping sale, if you got bank is your dad's wallet, then you can nothing can stop you to buy everything. Learning it with the Black Friday, most of the people shop got on the shop and tried to collect everything because there is a lot of sale, huge discounts. People collect a lot of things. People purchase a lot of things. So to understand that sort of scenario, if you are monitoring everything, so in this year, this sort of thing happened like X, your sales were there comparing to normal day. So you can understand like how many times it is. So it will eventually help you to understand how people, which product, which thing is people have purchased in that duration. So it will eventually help you to understand the analysis and understand and do the analysis for the next time, for future. Why we do analysis and monitoring to improve our application and for future prediction. And what manner it will drive the train, how to really train. So always there are some challenges. So let's see what are the challenges. data overload. Because when we collect data, we don't know what data is important, what and not to. So we always try to understand which data is important for us. So we don't capture all the data and make a stack of everything. Next is integration complexity because people nowadays have multi-cloud setup and using different things. So it is definitely hard to have an observability. So to integrate them, it is very difficult. The skill gap, sort of thing, people need to understand to implement AI/ML and their observability. So what are the solutions? So use automated tools to filter and process data because I already told you don't need to create the stacks of data, stacks of logs. You need to understand that data is important, but which data? Proper data, not every data. We need to understand, we need to set up rules to flag and isolate those logs which are really important for us, which are like security breaches or any significant which impacts our performance. We need to understand that sort of logs and we need to put alerts, filters over them. It says select, we will only select capture data. So what's our business object and that's the sort of thing we will collect the data. So we always need a unified platform because we have multi-cloud setup, we need observability where we go for logs with other environment, traces with other environment, monitoring with other environment, and it will always create chaos. We need a single platform where logs, traces, monitoring, everything could be possible. Even the alerts with different integrations with different third-party applications are always possible. For example, you can see middleware. So in middleware, you can connect with many databases, every cloud provider seamlessly. You don't need to put your lot of efforts there. So always a unified other platform is required. What's the future of observability and platform engineering? AI/ML integration because always, like I always previously discussed, AI plays an important role for troubleshooting. AI/ML like it's a Gen AI era now. Using AI to make our observability, our analysis more impactful. It can eventually help us to detect many things and will eventually help to make future decisions. Next is edge observability. So extending observability to edge computing. That's really a tough, very wide topic and eventually in next few years it will be a boom. Open standards, the grow of adoption of open telemetry, new releases, new features every time open telemetry have, and similar from some framework for observability is giving a lot of edge to people in observability space. Let's discuss some of the best practices for implementing observability. Start with clear objectives, implement end-to-end tracing, leverage automation, adopt a continuous improvement mindset, promote cultural observability in your company, in your space, regulate, validate observability tools and processes. So it's an end-to-end observability with platform engineering, why it's important, and you need to collaborate both of things to improve your performance efficiency of your application. With me for any queries. Feel free to reach out me. Any suggestions, any feedback will always appreciate it. Thank you. Have a nice day ahead.